Okay, we've got this piece of cardboard that's 12 by 15 inches long. We're going to cut a square from each corner of equal dimensions. And fold up the corner or fold up the sides along these dotted lines. And we'll get a box that looks something like this, where this dimension is x. This dimension is 12 minus 2x. And this dimension is 15 minus 2x. So the volume of that box is going to be length times width times height. And we want that volume to be at least 150 cubic inches. So let's see what's going on. Here's another example where we've got the 15 by 12. There's the squares cut from each corner. And there's a formula for the volume of the box. And it looks like when x equals 2, the volume is 176. Now, one question asked about the domain of the function. So let me share my screen. Go to Desmos real quick. And watch what happens when the side of that square gets closer and closer to 6. Eventually, we won't have sides to fold up anymore if x is equal to 6 or greater than 6. And of course, if x is equal to 0, we won't have any corners to fold up either, or sides to fold up. So the domain of this function is the set of all numbers x such that 0 is less than x is less than 6. Otherwise, you don't have a box. Okay. Now, how are we going to find out the values of x that we can put in here that will give us a volume of at least 150 cubic inches? Well, here's the volume. We want that to be greater than or equal to 150. And we want x to be between 0 and 6. So if you multiply this all out, subtract 150 from both sides, that's the polynomial inequality you want to solve right there. Not so easy because this thing doesn't factor. So I'm going to go back to Desmos and I'm going to plot the function v sub 1 of x equals 4x cubed minus 50 or 4x squared, etc. When I plot that function, the question is, when will it have a value that's greater than 150? Or that's greater than 0, actually, because I already counted for the 150. And there are the values right there, 1.275 and 3.293. So you can see right now, when x, the side of the square, is 0.84, the volume is only 115.47. But if I move into range, there's a value for the volume that's greater than 150. And as I move towards that I forget what it was, 3.293, still greater than 150, but at 3.3 or 3.294, the volume is not quite 150. So there's your answers right there. 1.275. X has to be between 1.275 and 3.293. How you were expected to solve that inequality for X, I'm not sure. You better talk to your teacher about that one. Okay, there you go. Hope that helped. If you have any questions, post a comment.